Hi, in this video I will present to you a self-driving car that I've made using neural net. I will discuss the current state of the project, some of the features I've implemented in the car, and I will show what it is capable of right now. Later I will discuss some of the drawbacks of my approach and possible ways to further develop and improve the project. It all started as a line follower I did using OpenCV module in Python. Over time, the car got faster and I started to mold my own tires to improve the grip and so on. But I sort of lost interest in this kind of vehicle because you can only get this fast when you are sending videos over Wi-Fi, which I will discuss later in the control flow diagram of the video. Around the time I started to learn about neural nets and I was amazed by what they are capable of. I was impressed with how Tesla and other car companies are improving in the field of self-driving cars, and I sort of wanted to try this myself, not as a line follower this time, but rather a real truck with lines, with signs, with traffic lights and so on. So I've built a truck with roundabout, this is not exactly a roundabout, more like a turnaround and intersection, and I've made some stop signs, and I asked my friend to 3D print me some traffic lights, which he kindly did. And throughout a couple weeks, because I was still learning neural nets at the same time, I kind of managed to make something that resembles self-driving car and drives itself on a track like so. So, the car is capable of detecting stop signs and behave accordingly to the driving rules, so stopping in this example. It is also detecting traffic lights, differentiate between red and green, and it is also detecting pedestrians, in this example members of the Beatles. The user can steer the car manually using arrows on the keyboard, but also using gaming wheel, which in a self-driving mode it is also moving, like you can see in a regular car. So let's discuss the control flow. The car has a smartphone attached, so there is no Raspberry Pi, there is no Jetson Nano or anything like that. There is only a smartphone and Arduino. And this is a standard Arduino Uno, and there is also a head for Arduino, but I only use it as a motor drivers. I use a app called Droidcam, which is sending video of what car sees to my computer over Wi-Fi locally, so there is actually no internet connection needed on the computer, and this is where all the magic happens. There is a Python script that takes the single frame of the video, put it through the neural net and produce a guess, which is a deviation from the center of the line, which is later used to calculate steering. There is another neural net for object detection, so signs, traffic lights and pedestrians, for which I used a trusty and fast YOLO v3. When the steering commands are ready, they are sent back to the smartphone via a custom app that I've made specifically for that purpose. It is receiving information through Wi-Fi, again locally, and with a help of OTG USB cable, it is sending the information to the Arduino, again because there is no Wi-Fi module on the Arduino, there is just standard serial port. The accuracy of the neural net is pretty low, it is about 50 or 60% on a test set. But even if it is mistaken, the mistake is really not that big, it is maybe about 10% tops. So the car manages to drive efficiently nearly all the time. Surprisingly, it even drives through a different track with different colors of both road and lane lines. Now, let's discuss some drawbacks of the method that I presented. First of all, using computer and sending information back and forth makes the car tied to the router. In reality, the car have to be within the range of 3 meters from the router to maintain connection and for the latency to be low enough to steer efficiently and react fast. This can be improved by opting for a onboard computer like Jetson Nano or Raspberry Pi. However, neural networks tend to be computation and memory hungry, so small onboard computer might not be handling this well. Second of all, there are a lot of things that could be done cheaper in terms of computation. There are methods for detecting simple shapes, so stop signs, for example. These don't have to be detected via neural net. Same with road lanes and center of the line. As I show in the beginning of the video, there are ways to detect lines with OpenCV. But like I said, I just wanted to try and see if the car can drive itself just using the neural nets. Lastly, there is no GPS involved, while today cars have really precise units on board. This would make driving through the intersection much easier, because the car don't have much reference points to learn from, and by moving my intersection around the room I can see that it sort of memorized the route more, and it is using furniture around to steer when it should really watch the lines. Implementing GPS and equipping the car with wide-angle camera lens, possibly more cameras, would solve the problem. Anyway, thank you for watching. All the codes are available on my GitHub, the links are in the description. If you have any questions, please leave a comment. Also, if you are interested in getting into actual code behind this stuff, let me know. I will make a video more in depth of what's exactly going in all the scripts.